Okay, we are still in chapter 2. This time we're going to put all of the different things that we've learned about polynomials together and use that information to graph it. Now it's still not going to be perfect graphs because we really need calculus to make them much more perfect and accurate. But we can draw rough sketches at this point, okay? And so the way that we put everything all together is the first thing we're going to do is use the leading coefficient test to figure out the end behavior, right? That's what tells us the end behavior, right? So we're going to kind of go through these and walk through the process here with 3x to the fourth minus 4x cubed, okay? So the first thing I want to do is use the leading coefficient test to determine the end behavior. So again, I have a polynomial of degree 4. Highest exponent is 4 here. It has a leading coefficient here that's positive. So that means I have an even degree with the positive leading coefficient, meaning that my end behavior should look like this. Okay? So the next thing that we're going to do is we're going to look at part 2, and that is to find the zeros and any multiplicity. Okay? So I'm going to set this equal to 0. That's what finding the zeros means. I put 0 in for y, and I'm going to look at this polynomial. Again, I have a greatest common factor of x cubed. Factoring is my friend, which gives me this in its factored form. Okay? So now I set these each equal to 0. So this x cubed equals 0, and then this 3x minus 4 is 0. This gives me x equals 0, and this one gives me 3x is positive 4. I'm adding 4 here and here, and dividing by 3. So this gives me positive x to the 4/3. So I have two zeros, right? This one, right, this one is just a single factor. This x, although it's a little bit deceiving because it's not with a, maybe it'd be more obvious if I wrote x minus 0 cubed here, but this x cubed has a multiplicity of 3 on it. And so that's an indication, right? At 1, when I just get a single factor, it always crosses. And when I get a multiplicity of degree 3, meaning it's showing up 3 times, I also get a cross there. Okay? So let's see what we have here so far. Okay, so I know I'm going to have the 0 here at the origin. That's my multiplicity 3. And then 4/3 is about 1.3, so that's about here. Right. Now I also know that my behavior should be up and up. Okay. Now, more than likely, because I have to go up, I'm going to come up here, right? I'm going to cut, because these are both cut throughs, I'm going to cut through here, I'm going to cut through here, and I should go up. Now when I get an x cubed like this, it's not usually a nice smooth cut, so we probably want to graph a few points in between. So that's part number 3 here, is that we plot a few extra points. So between 0 and this is 1.3. So let's say we need a point on this side, so let's use f of negative 1. So if I plug in f of negative 1, then I get 3 times negative 1 to the 4th minus 4 times negative 1 cubed. So this is going to be 3 times 1, because when I raise it to the positive 4, I get positive 1. And then this will end up being plus 4 here, because this will hold its negative sign, so I get negative 1 times negative 4, which gives me plus. So this gives me a 7. Okay, so then I have this point back here, 5, 6, 7, so that's up way up here. So I feel confident that I can draw my graph, this piece of it. Okay? All right, so let's also use 1. So f of 1, that's a nice easy one to figure out. That's just 3 minus 4, which is negative 1. Right, so I have this point down here at negative 1. And let's see, okay, so I feel kind of confident here that I should kind of do something like this. It's not a nice smooth, it's a little bit, it's smooth, but it's not like a straight smooth. It's kind of got this little tiny wiggle into it. Probably I should have graphed a half right here. I think it actually goes something like, not particular, kind of goes, it has kind of a little curve to it. And then I'm pretty sure it goes up like this, but let me just plot a point to the right here. We'll do f of 2. When I put in 2, I get 3 times 2 to the 4th, which is 16, minus 4 times 2 cubed, which is 8. So I get 48 minus 32, which gives me 16. And so, right, I'm way, way up here. So now this is not a very, I've done a very poor job of graphing this, but I know I'm going to have this 0 here, this 0 here, and this little piece in here kind of does this little curve thing. It shouldn't look pointed. It should look much smoother than that. Just go graph it on Desmos and then you'll be able to see it better. But this is the steps that we go to, and then we connect it with a smooth curve. I've done a very poor job of that because this is looking more like a point than a curve, but it should definitely be curved. So that's an example of how we put it all together. Okay, let me just draw one more since that was sort of a failure. All right, so let me look at one that's kind of in factored form here. Okay. So this time I'm going to deal with this polynomial. Now this is going to be, okay, so my leading coefficient test, first of all, I have to infer here. I don't really want to multiply these all out, but I see I have 2 factors here which would give me a quadratic, and when I multiply it by 1 more, I'm going to end up with a cubic function, x cubed. So my highest exponent will be x cubed. So that tells me there's no other numbers here, so I'm going to assume that my leading coefficient here is 1. It means that my start and finish, right, it'll be like this. So it'll start on the left down and then end up on the right up. So then I've got it all nice and factored, so my zeros are x equals 3 and x equals 1. Right, so I used my coefficient test and I already had it nice and factored, so let me throw in this x equals 3 and x equals 1. Those are my zeros. So I know that f of 3 is 0 and f of 1 is 0. All right, so these, let me put them on here. I have the point 3 here and then 1 here, okay? Now this one here, this x equals 3 comes from a factor with a multiplicity of 2 on it. So when I get to this 3, I should see a bounce. Now I know it's going to finish over here, okay? But what's going to end up happening here at 3 is I'm actually going to bounce up and then come back down like this. So now this is not a perfect graph, but I've just roughly sketched. I really should plot a point out here and in here and down here as well. But just really roughly, I just kind of wanted to show what happened. So this x minus 3 squared gives me an x equals 3, and at x equals 3, I should see this bouncing behavior. I know it's going to finish this way and end this way, right, like this.